Lucas, we'll start with you. Pythagorean identity, what is it? You got it. Sine squared theta plus cosine squared theta equals 1. And if you want to use x instead, that's fine. Doesn't matter as long as you have general form. All right, so what's next on your list? What's second? Secant and then cosecant, right? So there's two other Pythagorean identities. How do you derive both of those? Divide either by cosine squared or sine squared. Does it matter what we do first? No, I'll do the sine squared with you, and then you guys can do the cosine squared. So divide everything by sine squared. And this is really good practice with your reciprocal identities. Now go ahead and simplify each part. All right, Richard, what did you come up with?
I got 1 plus cotangent squared cosine.
You got it. All right. So there's our second Pythagorean identity. And it's not here. Greg, how do we find our third one? Now we're going to divide by cosine squared. So write out the Pythagorean identity again. And now we'll divide by cosine squared for each part. And simplify that one. Tangent squared theta plus 1 equals secant squared theta. And now we have our three Pythagorean identities, 1, 2, and 3, all coming from our first one, which is here. Questions on these? Okay. All right, look down at your sheet. What's our next derivation?
Sum and angle difference.
Sum and angle difference. All right. Do you need to memorize these?
Yes.
For sure. All right. So these you should have memorized. So we'll do sine, sum and angle, okay, and then I'll have you guys do cosine. These are you should have memorized. All right, Christian, what is the sine sum angle formula? Okay, well, let's write this first. Sine alpha plus or minus beta is equal to what?
Sine alpha cosine beta.
Mm-hmm.
Cosine alpha is
Plus, and what's going to go underneath? A minus, plus or minus, and then what's next?
cosine alpha.
Good, sine alpha. Same sign, right? You're doing the same thing. All right, and then who's got cosine for me? Eric. Oh, make sure you write your plus or minus in. So cosine alpha, cosine beta. Yeah, sine alpha or sine beta, either way. There it is. Good. What's the difference with cosine? Yeah, it's all the cosines are together and you do the opposite. There's your opposite. Okay. All right, now we have to memorize these because what do they help us come up with? The double angle, right? And I'll work through this one with you. So once we have this, now we got to do double angle. And double is derived from this one. How do we use this to get double? Menelek? Perfect. It's going to be sine of alpha plus or minus. Actually, we're adding, right? Plus alpha. Because now we have sine of 2 alpha. We have 2 of them. So based on what you did here, go ahead and expand this one. Expand it out. And come up with your sine double angle. Alright, so the only difference here, guys, is you don't have beta anymore. Beta. So this will go in place of this beta. So now we have sine alpha, cosine alpha, same sign, plus cosine alpha, sine alpha. And are these the same terms? Yeah, what's the only difference? Just the order, right? So how can we rewrite this simpler? 2 sine alpha, cosine alpha. So this would be your final answer on this one. Alright, so there's your double angle. You can see there's 2 of these. These are the same thing, the order is just switched. All I've done is replaced the alpha with my beta. Alright, questions on that one? Alright, do cosine then. Alright, so I'm going to work this one out. Cosine alpha plus alpha is the same thing as this, except beta is being replaced by alpha. And when we do cosine, we have to do the opposite. So instead of adding, we are subtracting. A lot of you guys got this far. But we can go a little bit farther. This is like x times x. So we have a cosine squared. So this would be cosine squared alpha minus sine squared alpha. And there's your double angle for cosine. Let's box this one. Questions on this part? Double angle for sine, double angle for cosine. You can see that if you write the formula wrong, are you going to make a mistake here? Yeah, so you got to make sure you nail this. How many more of these do we have? 2 more. Okay. And how do we transform it? What identity are we pulling from? Pythagorean, right? So I'll do the first one with you. By this point in time, you might just remember that cosine's 1 minus sine squared, right? So we can just go right in here. You know what? I probably should write it all out so you guys can see it. So Pythagorean identity, cosine squared is equal to 1. Now we want to write everything in terms of sine or cosine. So I'll just subtract cosine at the beginning. Something we've done a lot of. Some of you, you don't have to do this on the derivation if you just know this. But I'm going to do it so you guys can see. Alright. So we did this a lot in chapter 4 too. Moving, manipulating. So now we have sine squared equals 1 minus cosine squared. So all of this we can substitute in for sine. Because these are equal, right? So if they're equal, and this is equal to 1 minus cosine, we can take all of this and plug it in right here. So let's go ahead and do that. And be very careful with your parentheses. We get cosine, double angle, running out of room here, equals cosine squared theta minus 1 minus cosine squared theta. So literally it's the same thing, except I'm replacing sine with 1 minus cosine. Alright, simplify that. Come up with your second identity. Alright, so you'll see that this, I'll do this one with you. The negative goes to both, so it becomes minus 1, and negative times a negative plus cosine squared. So how many cosine squares do we have now? There's 2 of them. So we have a total of 2 cosine squared theta minus 1. There it is. Alright, so that's my second double angle for cosine. You know what? And why don't you guys find the last one now? This is the last derivation. See if you can find the last one. Instead of writing it in terms of cosine, write it in terms of sine. Alright, for this last one, same thing, go back to your original, but now instead of replacing this with 1 minus cosine, what are we going to replace this with? 1 minus sine, okay? 1 minus sine squared of theta, and then minus a sine squared of theta. And don't need a distributor negative here. We have a total sines, both of them are negative. So cosine double angle is equal to 1 minus 2 sine squared of theta.